Class enough. Listen, demons means people. Demons means people. Okay. And logy. What is the meaning of logy? You already studied terminology, right? Study. Yeah. It's the study upon people or study about people. Okay. That is the actual meaning, but it doesn't fit with the actual context of this subject. In reality, epidemiology dealing with, right now, it is a scientific study of, distribution, determinants means in the bracket you can write risk factors. Distribution, risk factors, determinants, risk factors, and occurrence of diseases in a defined population. Okay, it is all about distribution, determinants, and occurrence of diseases in a determined population. Okay, in a defined population. I don't know why some of you are smiling there, laughing there. If you are not interested, I am very happy to give you attendance and you can leave my class. I don't have any issue. You both want to go outside? You want to enjoy? Really, I'm not serious. You can give your UIAHS, I will provide attendance to you. If there are any people who want free attendance, not to sit in this class, they can leave. After that, I will call your parents. That's the fresh story.
Sir, may I go to wash my hands?
You want to leave?
I want to wash my hands.
Okay, listen. This is very interesting subject actually, very interesting subject. Listen. See, we know that cancer is a deadly disease. Okay? Let us assume some 10 students got malaria. Okay? Now what is the deadliest disease in this classroom? Is it malaria or cancer? Cancer. Now, malaria. Because malaria started affecting more people. More number of people started diseased. Now the challenge was to control the malaria, not a single person cancer. Cancer was affected only single person, but malaria affecting more people. Got it? So epidemiology always studies about the disease in a large population. Okay? This is not about study of a single disease. It's a disease in a large population, affecting a large population. Clear? Now I will use some important examples, maybe with a classical example. Let us take an example of malaria. Okay, very interesting topic, listen. So this is called as chain of infection. They are saying if we want to eradicate or to prevent any infection, first we need to understand its chain, how the infection transmitting in a population, just like a life cycle. So let us see what is the concept of chain of infection. Chain of infection. So a disease always starts with a pathogen, right? What are the pathogens we have? Bacteria, parasites, viruses, even fungus, right? So let us assume malaria is caused by a fungus or parasite. Then what? Parasite. Very good. It's a parasite. Can you tell me what is the parasite name? Yeah, Plasmodium. Very good. Plasmodium species. Multiple species are there. Falciparum, malaria, okay, anyway. Now listen. Now we have an agent. Our chain of infection starts with an agent. Pathogen or agent. Pathogen or agent that causing disease. This is number one. First we have an agent. Now what happens after this? Now this agent will present in some reservoir. Pathogens are present in some place, right? The place of presence of pathogens is called reservoir. Reservoir. This is the place of residence, place of reside of the pathogen. Actually, I prepared a nice PPT, but there is no projector anyway. So, can you give me few examples of reservoirs here? Few examples of reservoirs. Air, soil, yeah, air in a sense of virus. Then what might be the reservoir of malaria? Stagnated water. Very good. Stagnated water. Stagnated water. So, why stagnated water? Any idea? Why? Because we know that Plasmodium resides in a host. What is the primary host of Plasmodium? Primary and secondary host. Primary is mosquito, secondary is humans, ants, right? In the mosquito, the parasite will reside. So here we can say malaria as a reservoir. Mosquito. Can mosquito be a reservoir here? It can be a natural reservoir, a biological reservoir. What about the humans? That I will come later. I don't want to touch humans here, you will get confused. Keep it aside, okay? Don't go to psychic, like psychiatry. Okay? So, you got the concept, right? You understood what is a reservoir. It is the place of residence of any pathogen. In case of COVID, what is the reservoir? What is the reservoir of COVID? Air. Droplets, air. Or if you go extreme, the actual biological reservoir. What is the biological reservoir of COVID? Humans or the bats. They say bats are not what familiar. It's an anti-interaction. So reservoir. This is the second thing in chain of infection. Next. Now, this parasite present in this reservoir. From this reservoir, the parasite will exit the reservoir. Parasite will come out of the reservoir. That is called as portal of exit. Portal of exit. Okay, portal of exit. The parasite will exit from the reservoir. How the parasite can exit? Can you give me a few examples? Portal of exit. How a parasite or pathogen can exit from its reservoir? Let us assume it's a biological reservoir. If it's a biological reservoir, maybe present in a pig or a human. Okay? What might be the portal of exit for a human? If a person has a cholera, he became a reservoir with cholera infection, and the parasite want to come outside. Parasite want to come outside. That is portal of exit. What will be the routes of portal of exit in the human in case of cholera? Fecal-oral route. Am I correct? If the person going for fecal material, obviously in the fecal material the parasite might reside, right? Now exited from biological reservoir, the parasite exited by a fecal-oral route. Okay, fecal route. So that can be one thing. Fecal-oral route, oral route. Any other routes of exit? Genito-urinal route, either through sexual or through fluid exchanges. Genito-urinal route. Any more? Even your you can take even soil, water, that depends. Even food, that depends. Okay. Portal of exit. Now you know the concept of portal of exit. How the parasite exiting from the reservoir is called as portal of exit. Okay. After portal of exit, let us take cholera here. Cholera exited through fecal route. Now the cholera present in a fecal material. Okay. Excreta. Now the next step will be mode of transmission. From here, whatever it is, parasite present in the environment. Now, how this parasite transmitted to its next host? Always host is humans. This is a human medicine, right? So it's not veterinary science. So how this parasite entered to the human host? Let me say this is a host. Here, this is called as mode of transmission. How it is transmitted to the human? Give me few examples of mode of transmissions. How it can transport it. Any examples? Yeah, by air. Then Direct contact, maybe direct contact with this one. Next, this phenomenon we will see usually among children. Okay, white worm, pinworm infection in children. You know, in their fecal material you will see threadworms, white worms. Okay, very thin worms. Usually, what children will do, they will catch everything, mud, soil. They have a habit of touching their here and they will keep mouth. Children always habitual of this one. So it's a cycle for the parasite. So direct touch can be one mode of transmission. Anyone? Air droplets, you said moisture. Anyone? Via insects. This is one brutal problem. Insects will transmit most of the parasites. Anyone? Water. Then I just want to add one more here. Sometimes the environment can also act as a transmitter. The best example is called nosocomial infection. Do you know what is nosocomial infection? Yes. Very good. What is it? Hospital acquired infection. Here the hospital environment has pathogens. We might catch them. So if we catch an infection through the hospital environment, that is called nosocomial. Very good. So even A, that means hospital environment. Very good. Now you know the concept of mode of transmission also in the chain of infection, right? Then what might be the next possibility after mode of transmission? Now the parasite need to enter into the host. Portal of entry. How the parasite entering into the host? Portal of entry. Portal of entry. How it might enter? Give me few examples. How a parasite can enter into the human? Yeah. Route of portal of entry. Again, same things. Fecal-oral, genito-urinal, through ingestion, through food, through injection, through direct contact, through sexual contact, through substance abuse. People who will share needles, through them it will enter. Okay, that is portal of entry. Fecal-oral, genito-urinal, through food, then substance abuse, needles, etc. Okay. Now the parasite entered into the human. Next, what happens? That's it. Susceptible host. Now one host will get infection, and again the life cycle will go on. Now they are saying that this is the fifth step, and susceptible host 6. Now, if we want to break the chain of infection, if we want to stop spreading of this infection, we need to break any one of this chain. If we break any one of this chain, that parasite won't spread in the community. Okay, but we cannot take some daring steps, right? We are selfish, we are humans. We know that an infected human, if a healthy mosquito bited, a mosquito is healthy, keep in mind. A healthy mosquito bited an infected human. Maybe Miss Sandra, for example, okay? Maybe Miss Sandra has malaria and a plasmodium parasite wandering happily in her body. Now what happened? A friendly, uninfected, healthy mosquito entered there. Mosquito is good here, okay? Now what happened? Miss Sandra transferred her plasmodium to the mosquito. Now mosquito got infection. But we are not pity on mosquitoes here, right? That doesn't mean, okay, this is the chain of infection. Let us eliminate Sandra to break the chain. We can't take actions on humans. I'm sorry, I'm not telling you, right? Yeah, see, to break the infection, we need not to kill the people. Other than harming them, try to check other routes. Maybe remove water, because water is the reservoir of mosquitoes. If you remove water, mosquitoes cannot breed there. If there is no mosquitoes, they can't bite them. The chain will be broken. Right? Okay, now there is a challenging situation where you can't remove the water. Maybe you are in the Amazon water rainforest where there is water everywhere, you can't remove the water. Then what you need to take, maybe any other step. Maybe keep a mosquito net so the mosquitoes cannot enter to your body. Okay, they can't bite us. So yeah, if you break any one of the chain of infection, expect humans, that is called breaking of infection or stoppage of spread of infection. That is the concept of chain of infection. Clear? Chain of infection. So I'm not discussing about chain of infection in epidemiology. It's just a supporting notes. Now listen. Epidemiology is always about study of spread of disease in the population. What it's concentrating? Three things. How the disease distributed in the population. What are the determinants? What are the risk factors leading to the disease? Maybe people are can we connect any risk factor for malaria to the people? Can you give any one risk factor for malaria? Yeah, stagnated water is the risk factor for spread of malaria. So we need to know the risk factor. And next one, we need to understand the occurrences. What do you mean by occurrence? Any idea? When it is occurring, time period. Maybe in the winter, in the summer, or any rainy season. If we know these three things, we can able to stop the spread of disease in a population. Okay? For this, we need some tools, what we can say. We need some components to study the epidemiology, to study the spread of infection in a community. Now write down the components of epidemiology. I hope everyone maintaining running notes, right? Class notes. This is very important. Yeah. At the end of the day, I will throw on your face some material, maybe ChatGPT or some internet material. But finally, I will expect same notes in your final answers in your exams. So this is the best golden notes that you are getting. Not the notes I am sending in the group or weekend works. Even in weekend works, I will seek my own notes in your answers. If you won't deliver this one, definitely you won't get good marks. In this regard, I need to appreciate properly actually. There are few people who will write my points in my answer, in my exam. No, actually that will give more satisfaction to me. I thought and same thing she wrote. So she is my good student. So you should impress the faculty with their own content. Got it? A small tip to you. Coming back to my problem, where am I? Components of epidemiology. Write down the components first, then we will break down. Yeah, components of epidemiology. Take it snap. Write it, please. Don't get photos. Gen Z generation. Components, first one, population. Second, yes and T, stay quiet, okay, last bench I think. Second, frequency. Third, health-related conditions. Health-related conditions. Fourth, distribution. And fifth, determinants. These are the 5 components of epidemiology. They are population, frequency, health-related conditions, distribution, and determinants. Determinants means risk factors. I already discussed, right? Determinants, risk factors. So, what was the actual time? 4:10. This class is up to 4:40, right? So 4:40. Listen. You know what is 420 section? You don't know? It's a criminal section and illegal. Now listen. Very, very interesting things in epidemiology. Sometimes to understand the pathogen life cycle or chain of infection. For example, we got an unknown infection. Malaria we know, but suddenly people are falling ill. Many people dying. What we will do in that situation? Do we need to take an immediate action or shall we kill some people? We know that some deadly pathogen killing people, and what we will do actually, scientifically I am speaking, we will purposefully wait without treating the people. You know that fact? We will purposefully wait to see how this pathogen killing the population, what is its behavior, what population it is affecting. If the people are dying, what type of people are dying? Is it children, teenagers, or adults, or old people? And we also want to know what type of signs and symptoms are specifically associated in these dying people with that particular condition. We don't know what is that. We don't know, it's an unknown thing. But we want to get as much as data we want to build the chain of infection. We need to fill this map. Until we are getting this map, we cannot take a decision. We want to see how many people going to get affected. We want to see the frequency of people get affected. We want to see the health related conditions associated with the particular unknown disease to the dead or people. How the disease distributed in the population and how it is determined, the risk factors. One best example I will give. Everyone blaming COVID-19, right? Right? So COVID-19 means in what year we got COVID-19? 2019, right? But tell me realistically, in what year we got a lockdown? 2020. That too after March of 2020. See, the WHO already know there is some small outburst happened in Wuhan in China. Something people started, getting these COVID symptoms. WHO knows that. What is his name? Tedros Adhanom, right? The director of WHO. Initially people are blaming the director. You already know, you collaborated with Chinese, that's why you didn't say it because you want to protect economy. But what Tedros doing, he don't want to give that statement so-called pandemic, a global problem. Every day, now and then, there will be some localized issues around the world. For every issue we are saying it's a pandemic, how we will stop the world? The global economics, it will be it will collapse the stocks. So WHO is very shy at giving pandemic statement. And also parallelly, they are purposefully studying the population. Let them die. Let us gather the data. Is it affecting adults or children? Then we came to know adults are dying more. Believe it or not, we all see, right? Every day in our street, the people, mortuaries, they are coming, people are taking dead bodies, and most of them are old people. So now we got some satisfactory answer. Okay, it's affecting old people. All people are getting affected, but death is only for old people. This is called as mortality rate in the frequency. Who are dying? Mortality rate means the death rate. And which population, which age are dying. And next one, how many people are affecting in the beginning? 100 people are affected, but 20 people died, and out of 20, 19 people are old people. That indicates it's a old people specific. Mortality rate is 20 out of 100. So we are getting mortality rate. And morbidity rate. Can you tell me what is morbidity rate? Rather than 100 people, 70 people got infection and 20 people died. So 70 people is morbidity. Number of person catching infection is called morbidity rate. Okay. So that's it, students. Now I given some logical explanation to epidemiology as a whole. Epidemiology trying to understand disease for a large number of people, and it's trying to understand its behavior, its distribution, its frequency, and its risk factors among the people. Sometimes, very interestingly, this is not always affected by a pathogen. We need not to blame a pathogen for a pandemic or a global problem. Sometimes a disease can be affected due to the lifestyle of the population also. Got my point? What do I mean? Maybe in America, most of them will drink alcohol. Everyone, after 18 plus, everyone will drink. It's a part of their culture. So definitely there is a high chance of fatty liver and alcohol, liver failure. So that is a lifestyle issue disease. We cannot say that is an epidemiology of pandemic condition. Here, the people's behavior, their lifestyle affecting that disease. Right? So, yes, we also need to study the behavior of the population to understand the spread of disease. Okay? That's why we are always saying, right? Don't eat tobacco. Why we are saying? Because tobacco will trigger some other diseases in the population. Right? Tobacco might, connect the chain of infection. people are exchanging these things through tobacco. So definitely there will be some, droplet mediated infection in the population. So understanding epidemiology will give the overall spread of disease, and this will help us a lot. And what is the role of medical lab technician? Why we are suffering to study this one? We, every now and then, the government will take samples from the population, surveys. Have you seen this one in India? Some people will come with a notepad and they will ask, is there anyone feverish in your home? Is everyone fine? Is there any people wandering to your houses? Maybe in villages they will do this one, right? In my village they used to do it. They will, every 3 months they used to come and they will ask, is everyone fine? They won't give any treatment, just they will ask, that's it. If I say our grandmother is not well, they will note down. What they are doing was, they are taking the number of morbidity rates in that community. Oh, in this community there is a high morbidity rate, something affecting this community. Maybe that is not specifically TB or malaria, it might be something else. Something triggering this particular community to get some morbidity rate. Let us identify that factor, the determinant that is causing this morbidity. Maybe a simple street pump issue. Maybe water was contaminated somewhere that is supplying to this particular community. Maybe that is a triggering point of infection. So there are multiple examples that I will discuss in the next class. Now you got some clarity about epidemiology, right? What is the definition of epidemiology? It's a scientific branch. It's a study of distribution, determinants, occurrences of any diseases in a defined population. Defined is important here, right? And what are the components of epidemiology?
Population, frequency, health-related condition, distribution, determinants.
Distribution and determinants. Very good. And what are the parts of chain of infection? We have an agent, reservoir, portal of exit, then mode of transmission, portal of entry, susceptible host, and the cycle will go on. So clear, right?
Yes, sir.
Yeah. In next class I will discuss other things. Get ready for attendance.